All right. Now we are going to start chapter 10, which is on hypothesis testing for two samples. Previously, you have seen that we were working on hypothesis testing for one sample. We were discussing about means and proportions. We were trying to prove the claims for proportion and the means by using samples, one samples based on one sample. Then we were trying to figure it out whether the claim is true or false. For that, you have seen that the essential thing is that you have to state the null hypothesis and alternating hypothesis. Most probably, we write down the claims in null hypothesis, but hypothesis testing is fixed with the equality sign. So if the equality sign is with the null hypothesis, then you use the alternating statement, or the claim, you can write it down in your alternating statement. So we were figuring it out by comparing the value of P with the value of alpha, which is with the critical in the critical region. So in previously, we have seen that we were interested in finding the mean, where the mean and the proportion in your claim, which is equal to some specific number. So some specific number were given to you, like proportion the is equal to 0.72 or 72% people agreed with their some claims that they have their faith, like religious faith that is somewhat important. So that was the specific value was given to you. Now we are going to test between two groups. Here we will be having two groups and we are going to compare the data amongst the two groups. So when we are going to compare the data for the two groups, like two groups we are having and two statements we are having, and for instance, the one group has one sample mean, or another group has another sample mean. So now we are going to compare those population parameter for those two different groups. Then how we can do it? In this case, we will test if two groups have the same mean or the two groups have the same averages. So this is what somewhat will be finding it out in your claims, most probably you will see. So first one, in chapter 9, you were given a specific value for the mean or the specific value for the proportion. But in chapter 10, where we will be using two samples to estimate our claim, we will be comparing their sample, their population mean and their population averages. In like two groups, they have different population mean, then we are going to compare them that whether they are equal or not. We will be discussing it in a bit. So why these tests are important? These tests are important because when we have two groups that have different parameters, for instance, one group is something else, like for instance, I am comparing Mid-Michigan with Lansing College. So these are two groups. I'm going to check whether students in Mid-Michigan College are much more efficient than the students in Lansing in mathematics. So how we can compare them? We can compare their sample, their averages, like population average. Like let's say, I would say that the average score for the students in Mid-Michigan College is about 80% who takes grade A. And the average number of students who takes grade A is like 70% in Lansing College. So how you can compare those results. So this is what we will be looking at. Another thing is you will see that we will do some experiments on one group, and we are going to look at the effects of those things on a certain group that we will be discussing in this chapter. In a bit, we will be discussing. Let's see what it says. So I will explain it as far as we will be going. So again, two things are the same again, that you have to define what is your null hypothesis and what is alternating hypothesis. In chapter 9, you were looking at that whether the population mean is equal to some specific value. But here we are saying in null hypothesis that the two groups, they have their population mean for both groups, then in null hypothesis, we are going to check whether the both mean are same. Like students in Mid-Michigan College have their average score is equal to the students in Lansing College have their score is equal. They are equal. So this is my null hypothesis. I'm going to compare the averages of two groups. Alternating hypothesis is somewhat like opposite to the statement of null hypothesis, that no, they are not equal to each other. So the population mean for the one group or with is not equal to the population mean for another group. Or you can see some kind of less than or greater than, or I can say that students in Mid-Michigan College are much more efficient than the student in Lansing College in their mathematics subject. So then I will use that mu1, like if I'm saying group one is Mid-Michigan or group two is Lansing College, then I would write mu1 is greater than mu2. So then some sort of like greater and less than we will be using. Otherwise, we can say, okay, I'm not accepting this claim, then it means I'm going to use non-equality sign or not equal to sign. So the same thing, but in different perspective, you are looking at the null hypothesis and alternating hypothesis. Same thing as we were doing in chapter 9, we were doing z-test, t-test, and the proportional test, but that was only for one sample. So here we will be using two sample z-test, two sample t-test, and two proportional z-test will be looking at. So if for two groups, for both of the groups, you know their population standard deviation, then we will be using two sample z-test. If, for instance, for one group, you know one population standard deviations and you do not have any information for the population standard deviation of another group, then we are using two sample t-test. Or in another case, we don't know both of their population standard deviations, then in that case also you will be using two sample t-test. So for using the two sample z-test is important when you know the population standard deviation for both groups. Then you can use two sample z-test. Otherwise, you cannot use, you will be using t-test. And the next is if we will be looking at some kind of proportions that 70% of people are agreed with this statement or 70% of or 80% of people are agreed in another group, then we will be looking at two prop z test. So, and apart from this one, we will be looking at other test that is called for pair data t-test. We will be using pair data t-test when we will have information for only one group, but we are doing some experiment on that and we have two data given for the same group, then we will be using pair data t-test. So you will be looking, we will be discussing as we will go on. So what is where we will be using pair data t-test. So the next one is, again, we are using the same theorem consecutively in chapter 8, chapter 9, and now in chapter 10. We are using the central limit theorem that for large number of large number of samples that is normally distributed, and we are looking at their sample averages, average of the averages is centered at the is centered at the normally distributed curve, and you're looking at the sample averages, where does it exist. So then where if it is close enough, then we can see that our claim is true, or if it is far, then I can see that my claim is wrong. So using the same, again, using the same machinery for the central limit theorem again here. So, but as we are going to deal with two groups, so for sure we will be having more math in that. We will be looking more, we will be doing more mathematics. So it will be a little bit complicated, but not that much if you have understanding that what is going on in these questions. So if you will be looking for the standard deviation for the averages of the two groups, so it is some sort of like this one. Which is like the average of the standard deviations, but sort of like this. But you don't need to find it out because calculator will do it for you. You just need to know that standard deviations for the averages of the two groups, if you are looking at, then this formula you use. Or if you are looking for the standard deviation for the proportion of the two groups, then this is some sort of like this, which is the kind of the formula that you can look at. But you don't need to do it. The calculator will do it for you, but you just need to know that standard deviation for the proportion of two groups, what does it look like and what it is equal to. So one thing we will be using in your calculator, uh, we will be having, we can have two kinds of things for when you are comparing two groups. One is when you know the variances, because you know if you have one group, then the data is spread around the mean, and another group that has another data which is spread around the mean. If their variances are the same, then it is pooled data. If their variances are different, then that is unpooled data. The geometrically, you can see, for instance, if I have a group 1 and this is a group 2, so let's say this, for this group G1, the data is normally distributed. It's something look like this. And group 2 is something like steep curve you are having, which is normally distributed, but this is like this. So this is my mean, which is centered at the origin. So then when you can see that the data, the variance for sure is not same for G1 and G2, because it is more contract for G2 and more spread for G1. So variance will not be the same. So if variances are not same for two groups, then this is my unpooled data that we will be using in our experiments in chapter 10 in your calculator. We are not going to use pooled data. Pooled data is we are using when both standard deviations, the standard deviation or the variances are same for the two groups. So we will be using unpooled data in all throughout of our experiments. So what is example 1? Example 1 says a researcher wishes to compare body mass index for two different racial groups within the United States at the ages from 20 to 39. So body mass index is somewhat the ratio of your height with your weight. So that is gives you the body mass index. The CDC, which is Central of Control Disease, gathered the data and results of their study are given below. So CDC, Central of Control Disease, they are going to compare body mass index of two groups. One is non-Hispanic Black BMI and one is Hispanic BMI. So Black BMI and Hispanic BMI are two groups we are having. They have some data they studied and they are giving us this information. For Black BMI, they have sample. They collected some data. I don't know what kind of population size or the sample size they were having, but they found that the sample mean for Black BMI is 28.1 and sample mean for the Hispanic BMI is 29.3. Standard deviation for Black BMI is 6.35 and standard deviation, which is sample standard deviation here, not the population standard deviation. You remember that population standard deviation is always written with sigma sign. So if sigma 1, sigma 2 is written, that means this is population standard deviation. But in this case, this is S1 and S2, which means sample standard deviations we are looking at. So sample standard deviations for the Black BMI is 6.35 and sample standard deviation for Hispanic BMI is 5.60. Sample size for Black BMI, they were choosing 404 and for Hispanic BMI, the sample size they were studying 385 people. So this information they were having, we are looking at what we are looking at the mean. We are looking that the claim is that, what is the claim? Is there enough at this error, critical region alpha is 0.0111, is there enough evidence to reject the claim, or what is the claim that the average BMI for both groups is the same? So it means average BMI So we are looking for the average BMI for the first group. So let's say I'm going to write down average BMI for Black Hispanic, the group 1, Black BMI, sorry. So this is my, let's say mu1, and the average BMI for Hispanic second group, BMI, I'm going to represent it with say mu2. So first you have to choose which group you are choosing at the first group and which group you are choosing as the second group. Then we will be writing this subscript 1 for the first group and 2 for the second group. So because all the details you will be writing it under group 1 and group 2. So this has to be the same. So again, null hypothesis is that both groups have the same BMI. So it means mu1 average BMI for Black Hispanic is equal to the average BMI for Hispanic BMI for Hispanic people, which is mu2. So alternating hypothesis is that both BMIs are not same, or we are going to reject this claim. So that means alternating hypothesis is that their average BMI is not same for both groups. So which test we are going to use? Is it z-test, t-test, or the proportional test? Two sample z-test, two sample t-test, or two sample proportional z-test. Here we have seen that we do not have any information for population standard deviation for the first group and the second group. So we are using t-test for sure in this case. So we are having two sample t-test in this case. Again, I'm interested in the value for P. What is the P value? So in your calculator, you will go to stat, go to test. Here you will see number 4 is two sample, sorry. Number 4 is two sample t-test is given. So I'm going to select 4, two sample z-test. Now you will be looking at, if it is data, then raw data, then you will be writing in your data, which is L1 and L2. But we do not have raw data. We will go to stat. So in stat, you will see X1, S1, and N1. So N1 is for X1. We are choosing Black BMI. So X1, their average BMI we are writing. So this is X1 is given in your question, which is 28.4. SX1. SX1 is written, it's not S1, it's XS1, but it is the same thing as S1 because for first group, we are writing sample standard deviation, which is 6.35. N1 is the sample size for Black BMI, which is 404. Now X2 is 29.3, which is Hispanic BMI. SX2, which is a sample standard deviation for the Hispanic BMI, which is 5.6. And 2, which is a sample size for Hispanic BMI they are going to test, which is 385. And alternating hypothesis is not equal to, they are not equal. And here you see the pool data, yes or no. And we will be using unpooled data for all of our examples or questions. So I'm going to press no, means their variances are different for both groups. Then press no, and then you find calculate. So when I calculated, I have the value of P, which is 0.0348. So what is my alpha? Alpha in your question, which is 0.01. So it means P value is greater than alpha. So if it is greater than alpha, what is the conclusion? Conclusion is that we do not have enough evidence to reject our hypothesis. So it means null hypothesis we do not reject. Null hypothesis. So what is my interpretation? So if I'm not rejecting, so this means the average BMI for non-Hispanic Black BMI is close to the average BMI for Hispanic people in the United States. The average BMI for non-Hispanic Black people in the US is close to, we are not rejecting. If it is rejecting, p-value is less than alpha, then we can say it's not equal to the average BMI for the Hispanic people. But we are saying that we do not reject. So it means the both of their BMI is close to each other, is close to the average BMI for Hispanic people in the United States. So this is my evidence. This is my interpretation. In example 2, I want you to pause the video and read this statement and figure it out whether it is for mean and which test we are going to use, or mean or a proportion, or which test you are going to use, and how will you do it. All right. So a person claims that the arm length of men is longer than the arm length of women on average. So my claim says, so what is the person claims? That the average arm length for male is longer than the average arm length for the female. The CDC, the Center of Control Disease, studied upper arm length of males and females between the ages of 20 and 29. Their data is shown in centimeters. Test the claim that men have an average upper arm length which is longer than women. So you have to test this claim that whether male arm length is on average is longer than the female arm length. You have to test this with an error of, or with the critical region of alpha, which is 0.05. So for men, one group is men arm length, another group is women arm length. And all the information is given, which is X1 bar, which means that sample mean is given for the arm length for male. S1, which is sample standard deviation for male, is given, and N was one sample size for male they studied for 918 people. And similarly for the group 2 was assigned for women arm length, and X2 bar, which is sample mean for the women arm length, which is 35.7 centimeter. S2, which is sample standard deviation for the women arm length, is 1.95. And N2, the sample size for female, they studied 891 females. So again, the sample standard deviation is given, and we were talking about the averages. So average arm length, so it means it is related to the mean. So we are going to either use z-test or the t-test. So as we have two samples, so two sample z-test or two sample t-test we are going to use. Here we do not have any information for the population standard deviation for both of these groups. This is why we are going to use two sample t-test. So first of all, you have to write down your hypothesis. My null hypothesis says that the mu1, which is the average arm length for male, is, what is the claim? Is longer than the female. Is longer than the female. So first of all, you need to know that null hypothesis always has to be fixed with the equality. So first, I here in null hypothesis, I'm going to suppose that the average arm length for male and the average arm length for female on average are equal to each other, because equality sign is associated with the null hypothesis. Otherwise, my test will not work. H1, which is the alternating statement, now it is given in your question that the average arm length for male is longer than the average arm length for the female. So it means arm length for male is mu1 is longer than, it means greater than the average arm length for female. So this is my alternating statement. Now I'm not going to write not equal to. I'm going to write greater than, because in the question claim is given that the average arm length for male, which is my group 1, so mu1 I'm going to write down, is longer than, so it means greater than the average arm length for the female, which is for group 2. So mu2 I'm going to write down. So now which test we are going to use? Test is two sample t-test, because I do not have any information for the population standard deviation for both groups. Now I'm interested in the value of p. So again, go for stat, press test. On 4, you will choose two sample t-test. Go to stat x1 bar. Now you are writing all the values in your, that is given in your question, which is 38.9 x1 for male, S1 x1 2.15, 918, 35.7 for female. So now alternating hypothesis mu1 is greater than mu2. So I'm going to select the last one. Last one, I'm going to choose this one. And then pooled, which is no or yes. You will always write no, unpooled data we are taking. Then press calculate. The p-value is 0. So it means no value. So if p-value is 0, so what is my alpha? Alpha is 0.05. So p-value is greater than alpha, which is equal to 0.05. And p-value is 0. So what is the conclusion? Conclusion is that I do not reject H naught, which is my null hypothesis. Do not reject, sorry, this I'm going to write, this p-value is less than, I'm really sorry. So p-value is 0, so this value is less than. P-value is less than alpha, because alpha is equal to 0.05. Alpha is equal to 0.05. So alpha value is bigger. So if p-value is less than alpha, so this means conclusion is I am rejecting null hypothesis. So what is my interpretation? Again, if you are rejecting null hypothesis, interpretation. So if I'm rejecting null hypothesis, so it means alternatively, I'm accepting H1 in terms of writing. So it means what is H1? Mu1, which is the average arm length for male, is greater than average arm length for the female. So the average arm length of males is greater than the average arm length, or longer than, alternatively you can write it down, length for females or for women. This is my interpretation is. The next example, I want you to read, understand it, and think about it, which test we are going to use. All right. Example 3 is about the averages pay scales for the professors. Like the lawyer claims, a lawyer claims, what is the claim? That there is no difference. It means equality sign. No difference between the pay of professors at Central Michigan University and the professors at Western Michigan University. They both do not have much difference in their pay scales, in the pay for the professors. So they conduct the survey. A survey of 284 professors at Central Michigan University showed an average salary of 1,000 $108,500. A survey of 357 professors at Western Michigan University found that on average, an average salary in Central Western Michigan University for the professors is $109,600. If we assume that the population standard deviation in each case, now population standard deviation is given, in each case was $22,000, is the lawyer correct, or the lawyer claims is correct with the alpha value for 0.05? Now you don't have any data in table form. All the information is written in your statement. Now you have to write down, find out all the values to mention in your calculator. So first thing is, let's say my group 1, G1, is Central Michigan University, and group 2 is my Western Michigan University. In Central Michigan University, how many professors were surveyed? They survey N is 284 in Central Michigan University. And on average, sample average is 108. They found their salary is like this on average. And for sure, we do not have sample standard deviation in this case, because for both cases, they say on each case, the population standard deviation is, so X1 is this one, N1 is this one. Population standard deviation for both is same, which is 22,000. And then you have to write down the information for Western Michigan University, which is my group 2. In Western Michigan University, they surveyed N2, which is 357 professors. And on average, sample average, their salary is, they found $109,600. So again, population standard deviation is the same for both of cases in each case. So now you have to compare the population mean, like averages for these statements. So what is my null hypothesis? My null hypothesis is that there is no difference between the pay for the professors in Central Michigan University and the professors at Western Michigan University. So Central Michigan University is assigned with me 1. Their average pay is equal to the average pay for Western Michigan University. So there is no difference, which means there is a equality sign, and equality signs you always put in your null hypothesis. So what is my alternating hypothesis? Alternating hypothesis is actually opposite to my null hypothesis statement. So as there is no thing given, nothing like that is given in your question, that average salary is greater than of Central Michigan professors is greater than average salary for the Western Michigan University. So nothing like this kind of information is written. So it means you have to just reject or you have to accept this claim. So it means I am writing alternating hypothesis is not equal to mu2. Like average salary for Central Michigan University is not equal to the average salary for the Western Michigan University professors. So which test I'm going to use? Because now I have information for population standard deviation for both case are the same. So now I am going to use two sample z-test. On your calculator, now I'm interested in the value for P. On your calculator, press stat, go to test, So there is the third one is two sample Z test. So I'm going to press two sample Z test. Again, go to stats. There is sigma 1. Sigma 1 is your population standard deviation for group 1, which is Central Michigan University, and sigma 2, which is a population standard deviation for second group, which is which Western Michigan University. So in both case, I have the value 22,000. X1 is on average the salary for Central Michigan University, and X2 is the average salary for X2 bar is average salary for the Western Michigan University professor. So X1 is 108,500. Sample size 284. Alternating hypothesis now not equal to. I'm going to press not equal to. Pool data or unpooled, you have to choose. And then you will write down calculate. So p-value in this case is 0.529, round off to 4 decimal places. I'm writing it down, which is 0.5295. So what is my alpha? Alpha is 0.05. So it is way large than the value of alpha. So here p-value is greater than alpha. So what is my conclusion? Conclusion is that I do not reject my null hypothesis. So what is my interpretation? If I do not reject the null hypothesis, so it means I'm writing it down that the average salary of professors at Central Michigan University is close to the average salary of professors at Western Michigan University. The average salary of professors at Central Michigan University is close to the average salary of professors at Western Michigan University. So here is my interpretation. In the next example, a survey of 500 professors at two-year colleges in Michigan showed that an average salary of $79,083 with a sample standard deviation of 21,560. A survey of 35 professors at Mid-Michigan College showed an average salary of $63,956 is with a sample standard deviation of 15,170. Can we conclude that the average professor salary at Mid-Michigan College is below the average salary for 2 years Michigan colleges on average? So use alpha, which is 0.05. Now we have two groups. One group is 2-year college in Michigan, overall in Michigan, and second group is our Mid-Michigan College. So my first group, now I have to collect the information. The group 1 is all colleges in Michigan, 2 years, 2 years colleges. And group 2 is Mid-Michigan College. So we are talking about averages. Now we have to collect the information. As group 1 is for all 2-year college in Michigan. So N1, they choose a sample of how many professors? 500 professors from all colleges in Michigan, 2-year colleges. And sample size from Mid-Michigan College, they study for the professors is 35, which is this. N2 is 35 for the second group. For N2 X1 bar, average salary for all 2 years college, they found 79,000 $83, and X2 on average salary for mid-Michigan college professors of 35 professors they studied, which is 63,956. Sample standard deviation now is given for both, which is different. So S1 is for all colleges, which is 21,560. S2 is sample standard deviation for Mid-Michigan College, which is 15,170. Now you have to conclude whether the average professor salary at all Mid-Michigan, at Mid-Michigan College is below. It means Mid-Michigan College was my group 2. So it means mu2 is below, it means less than the all colleges in Mid-Michigan College, in all colleges in Michigan, which is 2 years college. So mu2 is less than mu1. This is my claim. We are going to test. So, but this is less than, this is why I will write it in hypothesis testing, not in alternating in my null hypothesis. So null hypothesis is that average salary for all college professors is equal to the average salary for the professors in Mid-Michigan College. This is my null hypothesis. So what is my alternating hypothesis? That is my claim is given in the question. Mu2 is my college in Mid-Michigan, and they say that Mid-Michigan College salary, professor salary is below. So it means less than mu1. Mu2 has to be smaller because mu2 is assigned with Mid-Michigan College. So now you have to choose which test. As we have sample standard deviation is given, so you will choose two sample t-test in this case. Now I will look for p value by using my calculator. So again, press stat, go to test, two sample on number 4, two sample t-test. Go to stat again. X1 is 79083. 21,560, 500 professors. So this is the information. I am writing it down on the calculator, and mu2 is less than mu1. This is why I'm writing it down. Mu1 is this thing greater than alternatively. So pooled is always no, unpooled data we are choosing, and then calculate. So now my p value is very small, which is, if you see e raised to power minus 7, this means exponential powers, which is 10 raised to power minus 7. So it means this is 0.0000006 zeros, and then I will write down the value, which is 8.34. So there is no point, will be further 834. So this value is way smaller than the value of alpha, which is 0.05. So P is less than alpha. So what is my conclusion? If P is less than alpha, that means we are rejecting null hypothesis. So if you are rejecting null hypothesis, or scientifically, I should write it down. It is 8.34 times so that you could see that why I'm writing it down here. 8.34 on your calculator times 10 raised to power minus 7. So this is why I'm writing it down in this way. So we are rejecting our null hypothesis. So what is the interpretation? If we are rejecting H naught, it means I'm canceling it out. So alternatively, I'm accepting H1 in terms of writing. So interpretation is mu1 is the average salary for all college in Michigan. So it's greater than mu2 is for average salary for mid-Michigan college. So it means the average, these things you are writing in theoretically, average salary only in the case when you are rejecting H naught, which is null hypothesis. Average salary of 2-year college professors in Michigan is greater than the average salary of professors at Mid-Michigan College. This is my interpretation. Okay, so this is my last example for today's lecture. The NASS records crop yields per year per acre in Michigan. So they crop the yields per acre. They get the records for the crop yields per acre in Michigan. In 2007, a sample of 28 counties in North and Central Michigan had an average of 142.98 bushels per acre of corn with a sample standard deviation of 22.71. Also that year, a sample of 27 counties in Southern Michigan had an average corn production of 158.01 bushels per acre with a sample standard deviation of 16.226. At alpha, which is a critical region, is given 0.02. Are the southern counties producing more corn per acre than the northern counties? Now we have two groups. You have to choose which group you are assigning with group 1 and group 2. Group 1, I am calling it as Northern Michigan, the crops field, the data we will be writing in Michigan, and group 2 is my Southern Michigan. In group 1, how many counties they tested, which is 28 counties, Northern Michigan, and on average, how many bushels per acre they found, which is X1 bar 142.98. Or sample standard deviation for group 1, which is 22.71. Now you have to write down the information for group 2, Southern Michigan, how many number of counties they choose, which is 27. On average bushels per acre, how much corn production they found, which is 158.01. S2 sample standard deviation for Southern Michigan counties, they found 16.26. Now with alpha, you have to calculate the value. So what you will do, I'm leaving it on you. You have to write your hypothesis, null hypothesis testing. So you have to choose what will be the statement. So claim is that the Southern Michigan, like group 2, is producing more corn on average than now the northern counties. So this claim you will be writing in your alternating hypothesis, which is in H1, that mu2, Southern Michigan, mu2 producing more corn than Northern Michigan. And H naught, if you're writing, so you will choose the equality that average corn per acre for Northern Michigan are both equal to each other. And then you will use which test, and for sure, because we are talking about averages and we have sample standard deviations, not the population standard deviation, which is same for both. So this is why I'm using 2 sample t-test. Then you have to calculate your p-value. Then you have to write the conclusion. And then you have to write the interpretation. If your p-value is smaller than alpha, it means you are rejecting H1, H naught, which is null hypothesis. So alternatively, you are accepting H1 in terms of writing. So it means average corn for northern Michigan is producing less than average corn for the southern um, per acre in southern Michigan. So if a p-value is greater than alpha, so that means we do not have enough information for H naught, for rejecting H naught. So it means their both production is close to each other. This is what you will be writing. I'm leaving it on you. So don't forget that test 2 and your homework for chapter 8 is due this week. So see you next week. Thank you very much.